thanks everyone for having us. My name is Daan Kuitenbrouwer. I'm one of the founders of Delft Circuits and indeed the commercial officer. So I'm going to introduce Adriaan in 1 second, but we're going to take it a bit more as a panel because downstairs we both have a lot of hardware standing, so we're not going to dive into too much depth, but more looking into how do we work together and how do we build the ecosystem approach together. So Adriaan, our Executive Director of Orange Quantum Systems, maybe you can briefly introduce yourself.
Yeah, thank you. So I've known Daan and Sal for a very long time because we're both from the Delft ecosystem. And I'm one of the founders of Orange Quantum Systems. That's a company that builds industrial scale test systems to test quantum chips. And these systems, in fact, look very similar to quantum computers, but they're really different. I'll be talking about that tomorrow and not in today's session. But I think a key characteristic is that these qubits typically operate in quite extreme environments. And think cryogenic, vacuum, these kind of conditions. And that means I need to get my signals to the qubits we're testing. And this is, I guess, why I'm here today, because this is the talk of Delft Circuits. And yes. I'm just here as a guest.
Thank you. So briefly about what we do. We make I/O or cabling, and our product is CryoFlex. So this is cryogenic I/O, so the cold I/O, which is also flexible. So what we do is we connect control electronics to quantum processors, all the way from the warm area to the cold. So we have this big thermal bridge. We need to bring a lot of signals in a very confined environment, very confined space, and also we need to work with high frequency signals. So downstairs we show more about how this flex is actually built up, but I would like to dive a bit more in like our role together. So as a solution provider, if you go for cables, what is your first thinking and what do you do?
I think the first thing to realize is that if you're delivering a solution to customers, is that the customers, they buy your product because they don't want to deal with excuses about, yeah, but this one little component was a problem. So that means that in the end, if it works, the customer's happy. If it doesn't, they will yell at me and not at my supplier. So the most important thing for me when looking at suppliers is that I don't want the newest thing, I don't want the new features, but I need something that works extremely reliable. I need to know what I got, and I need to know that if it does go wrong, we'll be able to fix it, and we're doing that. And then only after that do you start worrying about, well, I don't want to pay too much, but the single most important thing for us is reliability.
Reliability. Okay, so yeah, that's a very important point for us. So as a company, we're not focusing only on making flex. We actually focus on the complete solution there. But maybe you can give me a couple of hints, like what technical aspects are you looking for? And I'm going to go over like how we address that.
Yeah, so I think that's also a very, very good segue. So the other thing is that, well, we make very large and complex systems. And that means that if I'm going for a component, I don't want to have to design it myself. I want to set the requirements and the specs. And in this particular case, we're working in an industry there are no standards. Like everything is very immature, so to say. So to some extent, I really want to know what's going on, but not too much. So in this case, if we have a particular qubit modality, I might say I have these types of lines. I want to have this many of them. And I want you to make sure that it works in a cryogenic environment. It's resistant to multiple thermal cycles. My qubits are properly thermalized. I can come up with these kind of requirements. And then I want to be able to test that. So that's important for me.
Yeah. Yeah. So what we did in this case is basically we look at their system. We look at the number of qubits, the type of lines, the signal integrity question. And then we go into a designing mode. So what we designed the entire flex setup with our in-house software. It's called CryoSuite. And then we go, the design consists of a mechanical design, making sure that all the mechanical aspects, the thermalization, the vacuum feed-through fits in the fridge. There's an electronical side or microwave aspect to it, and obviously a thermal aspect. So you have to do that total thing. And then where we go at is we make a design and we go together to make a design freeze. And at some point, Orange says, okay, this is good enough. Let's go manufacture. So we manufacture the whole thing and then eventually install and do the quality control. And yeah, of course, cables end at cables, but as a solution provider, what we make sure is that it really works. So we come back and make sure that it actually works in the full system. But I would like to go back a little bit at where we started. So maybe you can talk about Impact One, or what was that project?
Exactly. So I think I started with mentioning that I've known Daan for quite a long time, and it really started already well before we founded our company. And one of the things we did way back then, and it all boils down to what we're doing today, is, well, if we want to build complex systems, we need to have reliable suppliers. So how are we going to find that? And then I think we're back to the ecosystem theme of this talk. And we said, you know what? Let's go talk to all the companies in Delft, sit together and see if we can make a quantum computer in 3 months. And we did. And the only reason we could is because all of it had previously done this in our academic lives, and all the different companies put together parts of this. So this was, she referred to Impact One, where we said, okay, well, let's take what everyone does. We took up the role as the systems integrator of that, well, demonstrator. It's also 1 qubit system, so quite modest, but really something you can just, fund based on your best effort and the resources you have available.
Yeah. This was back in 2021, and so in 3 months it was done. It was really quick, but it worked. So the big learning for us is, like, we can do this. We can build a quantum setup. So let's move on. And then 1 year later, we did a 5 qubit setup, which was called Impact NanoNISQ, where we also we did the complete wiring tree, and we said, okay, let's run a little algorithm on it, and it also worked. So that was really great. But there was also some further learning, and I thought you had quite an interesting.
Yeah, I think it was a really nice, successful project in the sense that we ran an award-winning algorithm to solve a differential equation on that system. So that sounds very cool. But what we also realized is that if you want to take this to the next level, you need to have commercial incentives. And the reason you need that, it's not just about the money, but it's really about sort of the dynamics. Because until that moment, we were sort of a first among equals, where we were sort of coordinating things. But we started with, as a solution provider, we're the ones that get yelled at when it doesn't work. And the thing is, if you're working as a consortium with, let's say, a subsidy project, everything is best effort, which is great, but it also means that if one of these suppliers is not performing, well, they're not a supplier, they're a partner. So you're always limited by whoever is underperforming, and there's no real incentive for everyone to step up. And I think, and this is really something that I'm convinced of, if you want to take it to the next level, you need mature industrial dynamics and commercial incentives, which says, hey, there's a supplier, and if you're not delivering on spec, I'm not paying. Yeah. And that's quite fundamental, because also I don't get paid if the total system doesn't work. And you really start to think very different about risk and what you're promising if those hard conditions are in there.
Yeah. And I think that's an interesting story, because you started off with, we all knew each other, we were kind of friends, and this nice vibe together, which is obviously great, and we organized the ecosystem quite well, but it doesn't really bring you to the end point. At some point, you must do the hard thing. You must say, okay, do you make the best wires? Yes, then we continue working with you. No, then not. So then the next step was actually to work towards another project, which was called Character, which is more in line with the bigger things you do now.
Yeah. So
maybe you can say, like, what did it work? How did it go there?
Well, I'm quite happy where we got, but I should explain a bit what it is. So what we did next is that, hey, we want to build a big system for a paying customer. We had these customers also like in the funnel and lined up. And the key thing is you want to go about figuring out not just can we do something nice when we're in a playground together, but hey, does it really work one-on-one with specs still in a nice, friendly, collaborative environment? But you can think of this really as a pilot project where you're sort of really saying, hey, we want to design something. Can we test it? Can we test in a work environment? Can we test the relationship? And then once it does become serious, because I do want to emphasize that the personal relationship and the ecosystem aspect of it means that you have the relationship, you have the personal connection, and it's really critical once you get to the point where it gets tough, that you do have this shared values and history to fall back on.
I see that we have half a minute left. I want to ask you one more question and what it means for us. So what is next for you guys, and what does it mean for us that we have to do?
Yeah, I think it's quite simple. If you look at the future, we need to establish an exponential development pace. We've seen the talks this morning of IBM and Google. we need to speed up. And I think that means that I need to get twice as cheap or cost effective every year. And that translates also to my suppliers.
Yeah.
So the question I have for you is, do you believe in the exponential, or do you have a stake in preserving the status quo?
And that's a nice question. Of course, we believe in this growth. So what we need to do is three things. We need to make sure we can get that price down, and that's basically by making more channels in the same space, making smaller connectors or cheaper connectors, and making sure that the signal integrity remains at spec. And do that basically, as you say, as the volume scales, the pricing of the total system shouldn't go up because it eventually becomes too expensive. So while driving that cost down. And we're very committed to actually deliver that to you guys, and we hope to the rest of the audience as well. Yes?
Thank you very much.